Okay everyone, this is a final exam review for Astronomy 112. The exam is mostly focused on the last quarter of the course, but will also include questions from previous parts of the course too. So let's just go through different parts, and you can feel free to be in touch with any questions. First part of the exam will be about the Milky Way, so you should know the different parts of the Milky Way and what kinds of features you might find in there. So for example, what kinds of stars would you find in the disk versus the bulge versus the halo? What kind of galaxy do we live in? You know we live in a barred spiral galaxy, and we're about 3/5 the way from the center of it. The oldest stars in the galaxy are in the bulge and in the halo. Youngest stars are, of course, in the disk, where all the gas and dust is, from which stars form. Stars are forming right now in the disk, in the spiral arms. Spiral arms are described by the density wave theory as a density wave happening in the disk of the galaxy, so like a shock wave that's creating star formation, and that's what we see as spiral arms. We know where we are in the galaxy by using triangulation. We measure the distance to globular clusters and then triangulate our distance from there. What wavelengths are best for studying our galaxy? Our galaxy has lots of gas and dust, and so wavelengths which can penetrate gas and dust, such as infrared, radio, microwave, X-ray and gamma ray, are great for studying the galaxy. Visible light, which dust blocks, is not very good. So if we want to study the center of the galaxy, the worst wavelength we can use is visible light. Better wavelengths are infrared, radio, and X-rays. And in the center of the galaxy we find a very strong radio and X-ray source, which is evidence of the area around the black hole. So that's part of the evidence for a black hole at the center. Also, we look at the motions of stars in the center of the galaxy and find that there's something with a lot of gravity there that's causing the stars to revolve very quickly around the center. That's also a piece of evidence for the black hole. Where is there dark matter in the galaxy? Dark matter is spread throughout the entire galaxy, but it's mostly concentrated in the halo. So 80% of the halo is dark matter, and we live in the 20% that has luminous matter in the disk of the galaxy. Okay, moving on. Other galaxies, there are other types of galaxies that we study in the course. There are spirals, ellipticals, or regulars. Know about the different properties of them, which ones have old red stars, more blue stars. We did a lab based on this, so you should have that down pretty well. Know about the different classifications, barred versus normal spiral, irregulars, ellipticals, just the basic classifications is fine. Large-scale structure, you know from that chapter, galaxies are distributed in large webs or strands in 3 dimensions, and so this is called the cosmic web. There are long chains of galaxies called walls, and areas where there are very few galaxies called voids. And the Hubble law is one way of measuring the distance of those galaxies. We find the galaxy's velocity through its redshift, and then we can correlate velocity, redshift, and distance using the Hubble constant. Okay, so if you find the redshift for a galaxy, that tells you its velocity, and knowing the Hubble constant, you can use velocity to convert the distance. The Hubble law is also important because it hints that the universe is expanding, that the universe began expanding some 13.8 billion years ago and has been expanding since. So the Hubble law allows you to measure the distance to galaxies and also indicates that the universe had a beginning. Cosmology is the study of the origin and evolution of the galaxy as a whole. Evidence for the Big Bang includes the cosmic microwave background radiation, which is the leftover light from an early period in the universe's history. Other evidence for the Big Bang is the expansion of galaxies through the Hubble law. Other evidence is changes in the abundance of stars. Stars have changed over time, galaxies have changed over time, and the galaxy has complexified and become enriched over time through supernovae recycling heavy elements. Age of the universe is measured through expansion of the galaxies as well as the abundance of elements over time. Olber's paradox asks the question, why is the night sky dark? And the question has its origin in the 19th century, where people believed the universe was infinite in extent and infinite in time period. In other words, it's eternal. If that were true, then the entire sky should be ablaze with light, and that light from every single star would have reached the Earth by now, and the entire sky should be filled with light. That's not the case, and so we know that one of the assumptions is incorrect. Well, the universe may or may not be infinite, but we know now that the universe had a beginning, and so that's part of the solution to Olber's paradox is that it indicates that the universe had a beginning because the night sky is dark. So think about that. There's more information on that in the book as well. History of the universe, know some of the major events that took place in the history of the universe. The initial one being the Big Bang, formation of basic elements, a recombination period from which the cosmic microwave background radiation comes, the Dark Ages, which is when there was hydrogen and helium gas but there weren't stars yet, the first stars, the first galaxies, then complexification, which leading to planets, and eventually life. So just know the basic eras in the history of the universe and what kinds of things took place then. So that's the majority of the material, and then there'll be some material from previous chapters, such as basic stuff like size and scales of things, how big are stars versus planets, galaxy clusters, that sort of thing. Remember your scientific notation. There'll be some questions about that. Light, we spent a lot of time on light, so just review the light chapter. Know that light, energy, and frequency are all related, and the different types of light that make up the electromagnetic spectrum. Telescopes, you know now that the largest telescopes in the world are reflecting telescopes, which use mirrors, versus refracting telescopes, which use lenses. And the important factor in a telescope is the size of its mirror lens, which determines how much light it collects. Stars, know about different types of stars, different stages, where's the sun in its life, what part of the HR diagram would you find it, how do we know basic properties of stars, that sort of thing. And then just the basics of stellar evolution. What happens over the course of a star's life, how does it change, how are high mass stars and low mass stars different in terms of their life cycles and their eventual states. And yeah, so just history and life cycles of stars. Okay, so the questions for the exam are fairly straightforward. There'll probably be between 50 and 60 questions on the final. You have a good amount of time to complete it. The exam begins tonight, Friday at 12:01, which is really Saturday, and runs through next Monday to 11:59 p.m. Okay, so good luck on the exam. Feel free to be in touch through email if you have any questions. And that's it for now. Thanks so much.